Our topic for today is multiplying and dividing surds. Now you will remember that when we started talking about simplifying surds that we used this rule. Square root of xy is equal to the square root of x times the square root of y. And we can use exactly the reverse of that rule to multiply surds. So for example, well not for example, the actual rule that we're going to use is square root of x times the square root of y is equal to the square root of xy. Example, square root of 2, let's use blue just to keep it easy to see, square root of 2 times the square root of 3. All we have to do is multiply those two numbers under the surd together and we get the square root of 6. This can be done also with slightly more complex ones. Say for example 2 square roots of 3 times 3 square roots of 15. Now while that looks like a more difficult problem, it's actually not. All we have to keep in mind is it's just like multiplying together terms when you do algebra. We multiply the two numbers together first. 2 times 3 is 6. And we multiply the numbers under the surd together just like this, and we get the square root. 3 times 15 is the square root of 45. Now you also always have to remember that you need to be able to simplify at the end. So I've left my square factors over there. What's the biggest square factor that will divide evenly out of 45? Well, that would be 9. So 6 square root of 9. What's left? 5. And then we say square root of 9 is 3 times 6 is 18 square roots of 5. And that is how we multiply surds. We can do a similar thing when we're dividing surds. So when we're dividing surds, you'll recall that the rule was the square root of x over y is equal to the square root of x over the square root of y. And when we're actually doing the division, rather than the simplifying here, what we want to do is go the other way and say the square root of x over the square root of y is equal to the square root of x over y. Here's an example. Let's try negative square root of 10 divided by square root of 2. Now, I find division problems are almost always easier if we write them as a fraction. Let's rewrite this as negative of the square root of 10 over the square root of 2. And we can combine that into one fraction under the radical, which gives me the negative, don't forget that the negative is outside the radical, the negative of the square root of 10 divided by 2. I think you can realize fairly quickly 10 divided by 2 is 5. So we're left with the negative of the square root of 5. Again, just like with the multiplying, we can do this with more complex ones as well. But this example, 12 square root of 8 divided by, or square root of 18 rather, sorry, divided by 3 square root of 3. Now again, just like with the multiplication ones, we do the numbers first, and we get 12 divided by 3. Actually, 12 divided by 3 is 4. And then we can combine these into one radical, or one surd. So we have the square root of 18 over 3. And 18 over 3 is, of course, 6. So we get 4 square root of 6. Now, we can also do these sorts of problems with the distributive law, which you've learned previously. When we're trying to expand brackets, what does the distributive law tell us? The distributive law says A times B plus C is equal to, we multiply these together, AB, plus, and we multiply these together, AC. Okay? We can do the same thing with surds. So let's say, for example, that we had the square root of 3 times 3 square roots of 5 minus the square root of 6. Okay? We can do the same thing. We multiply what's out here by each of these. I'm going to actually write down this step, although you might not need to whenever you do it. I'm going to multiply here first, which gives me 3, square root of 3, times 3 square root of 15. Now I have a minus in the middle, and I'm going to multiply the other one, which gives me root 3 times root 6. And then we just have two smaller multiplication problems. So we multiply the numbers together. There's a 1 and a 3, which gives me 3. 3 and a 5 gives me 15. And then I have 3 times 6 is the square root of 18. Neither of those numbers can be simplified. There's no square factor that can be divided out of either of them. Or is there? Wait. Look here. That 18 has a square factor that will divide out of it. What will divide out of it? 9. So we get 3 square root of 15 minus square root of 9 times the square root of 2. Square root of 9 simplifies, and we're left with 3 square roots of 15 minus 3 square root of 2. And because those are not like surds, the numbers under the radicals or under the surds are different, we cannot add or subtract them. We leave them just like that. Let me give you one more example of the distributive law and how it works in a problem. Let's try this example. 3 root 6 bracket 2 root 10 minus 4 root 6. Again, as we distribute, we multiply this part times this part. We multiply this part times this part. And I'll write down this step. Once you get familiar with these, you don't necessarily have to write this step down, but it may be helpful to your thinking. So we have 3 root 6 times 2 root 10. What's in the middle? A minus. Then we have 3 root 6 times 4 root 6. And then all we have to do is multiply like we did before. So we get the numbers together. 3 times 2 is 6. 6 times 10 is 60. Minus 3 times 4 is 12. And 6 times 6 is 36. Now the first question I have is there a square factor that will divide evenly into this? We certainly do. 6, and that becomes, what's the factor? 4. So it's 4 times 15 is 60. And what do we have? Well, that is in fact a square number. So we'll go 12 times 6. Now over here we have the square root of 4, which is 2, times 6 is 12, root 15, minus, then we have 12 times 6, which is 72, and we're done with our problem. And that is multiplying and dividing surds.